deal with. I don't know if I've answered.
Yeah, thank you very much. And I think it's something that we can pick up later on, across projects as well.
Thank you. Thanks for the question, Marco. So we're moving into the final presentation and the sort of wrapping up of our session. And but it's maybe the last, but it's certainly not the least in terms of importance. So we are delighted that we have Sacha Jones, who is the head of Open Research Services and manages the Research Data Management Facility and the Research Data Team here at the University of Cambridge. She is responsible for providing services, resources and support in the areas of research data management, open research and reproducibility. So we're delighted to have somebody who not only does all of these things, but is also an archaeologist by training, so perfectly placed to speak to this topic. Sacha, you're going to talk about data preservation and long-term data storage, which I think is a really important consideration and something that we've all been thinking about in detail, but we certainly need to think about much more. Thank you, Sacha.
Thank you, Rebecca. Thanks for the build-up as well. No pressure. Well, hopefully I'm gonna because we don't have that much time left, but I'm gonna keep this on the light side, but I think it's gonna tie lots of bits and pieces together from throughout the morning. Okay. Right, so I always include this slide when we're talking about things like this, because often the concept of what research data are can be quite narrow in some people's views, but really it's basically any data that you collect during the course of your research that underpins your findings. So it could be your field notes in your notebooks, photographs, maps, and then the normal things that we think of as data as, spreadsheets and so on. So that's what I'm talking about today when I'm talking about preserving data, storing it, looking after it, and curating it, because that's essentially what this is about. So what is data preservation? So it is essentially, it's taking steps to ensure your data can be found, understood, and used in the future, or for as long as necessary. So to just qualify that bit, for as long as necessary, that's quite important. So Stefania touched on this with reference to sustainability and thinking about the environmental impact of the amount of data that we collect. It's not necessary to keep everything. So part of data management is going through that process and deciding what do you need to keep, what should you keep, and what can be discarded. So for example, do you need 20 versions of a database, or can you just cull them periodically during the course of research? It takes time, but it's really worth it, both for yourself financially and for the environment as well. So from a kind of conceptual level, I'm going to explain this a little bit more in some other slides down the line. Data preservation might involve converting non-digital to digital, transferring born digital material to systems optimal for preservation. So that is data that starts off as digital data. So for example, a photograph not taken on film, but taken with a digital camera. It is also bit level preservation to ensure files don't change over time and behave as expected. So this is to ensure that files don't become corrupted over time. And then there are some specific ways of doing this. It's very technical, but it's where you put files through a preservation system, and you package them up so that they're protected in the future from corruption. And there's ensuring content can continue to be read in the future. For example, if software become obsolete, so perhaps think back in time to certain scenarios where you may have lost access to particular files because you no longer have access to that software, or it just doesn't exist anymore. I know I've experienced that before as an archaeologist, where I've lost access to old files because that software no longer exists. So it's preparing for the future when it comes to that. And it's archiving data in locations that provide digital preservation services. I'm going to be talking about that quite a lot here, and that's where I'm going to focus on repositories. So we've already heard about that a bit today from about the DANS repository and also open context as well. So this is like a dual talk about data preservation and also long-term data storage, but the two overlap massively. I think you can probably guess why. So what is long-term data storage? So it's keeping and storing data after the work has been completed. The length of time depends on lots of different things. Long-term is a very arbitrary term. So you need to consider how long you might need to keep data for. So for example, your funder, if you have one, or the sponsor, whoever is paying for the research, may have particular conditions or terms of providing you with the funding where they state how long you need to keep the data for. So it's really important to be aware of any terms there. For example, many funders, it's to keep the data for at least 10 years post the project. For others, it could be 25 years, but it also depends on other factors too. Your institution may have defined data retention periods as well. So look into those, it will vary across the board. How long you keep something for also depends on the availability of copies elsewhere and where those copies are stored as well. And that's where it's really important to have an idea of responsibilities. Who is responsible for what data, and are those data being protected so that they can be accessed in the future? And then finally, it also depends on the nature of the research and the repeatability of data. And I think archaeology is particularly interesting here because there's a lot of the research that cannot be repeated, either because sites are at risk of being destroyed or are already nearly being destroyed, or excavations are done and you only get one chance at that. Yes, you could put in a pit close by to the nearby one, but you will likely get different results. They may be similar, but they're different. So the notion of reproducibility is one that doesn't really apply easily to most areas of archaeology. So with archaeology, I think keeping the data in the long term is a special interest to the discipline. So well beyond the 10 years that is often stated by funders. So why are these two things important? So good data preservation and good long-term data storage essentially enable you and others to access and reuse the data, to validate findings, to build on existing knowledge, and to make new discoveries. So this will become clearer during the course of the rest of this talk. So you might be asking yourself now, what exactly do I need to do? Because we've been talking about this in the abstract. So hopefully now I'm going to give you some practical tips on how you can put data preservation into practice. So exactly what you need to do to look after your data. One key message is do not leave data preservation until the end of the project. It's tempting to do this because it's always thought of something that you need to think about at the end once the project is finished. But really, there are certain practices that you can follow throughout the course of the research life cycle. So from the point when you start collecting data or planning what data you're going to collect until the very end. So think about converting non-digital to digital. So if you have field notes, or you have maps or scribbles on maps or pins on maps or anything, think about just taking a photograph of it and using that as your backup. So back up your notes, anything in writing, anything that's not digital in some way. Upgrade your storage media. So this might be quite a frightening thought to a number of you. It is to me, that has lots of personal information like photographs, family photographs and such on external hard drives, but they do have a lifespan. and think of that lifespan as a few years, possibly up to 10 years or so. But think about changing your external sort of storage media. So I'm thinking external hard drives. USB pens are generally kind of a bad idea as a long-term solution. In fact, they're not generally a bad idea, they are a bad idea as a long-term solution. So think about upgrading your external hard drives on a regular basis. Keep backups. So we recommend to researchers at university to back up your data twice and keep those backups in separate locations as well. Separate physical locations. One of those locations could be the cloud as well. We've already talked about file formats. So save your data in open or common file formats where possible, and as you're going along as well. So export your Access database into CSV as you're going along. Keep snapshots of it in that way. But certainly when it comes to storing your data in the long term, do use open file formats so that the data remain accessible going forwards. And organize and describe your data. And I think Junaid's talk put this across very, very well with all the different types of metadata that are being collected about the data, and also the different sort of standards or common vocabularies that are being applied as well. And I think this is an area that I think archaeologists are particularly good at, because context is everything. So think about that providing that sort of context, the provenance, the description of the data that you're collecting, so that you and others can understand it in the future. And then lastly, deposit your data in a trusted data repository. And I'm going to fully expand on this in the sort of latter half of this talk. In terms of options for long-term data storage, a lot of this depends on what's available to you, what is available to you as an individual, what's available to you as an institution or an organization, a research group, what's also available to you in terms of funds as well, and ongoing funds into the future as well. So I've put up here 3 options. I've already discussed external hard drives. I think they're fine as one of your backups, but as long as you have another backup as well, that it's not just that and you replace them regularly. But there will be an ongoing cost with those as well. There's cloud storage too. And there are various options out there at various different prices, but the more you store, the more you'll spend, and there will be an ongoing spend for that cloud storage as well. If you're at an institution, then you may have access to particular servers where you can have storage space on there. Junaid mentioned cold storage, which is one of the offerings at the University of Cambridge for infrequent access to research data and storing it in the long term. But there are also costs involved with these things, and access might not be available to everybody. And also with all of these things, you need to figure out who is responsible, who has access, what is the long-term plan going into the future in terms of those responsibilities, that access, and who is going to pay for storing those data. And also you need to consider, is there an additional backup as well? So for example, you would not want to put all of your data just on the cloud, or all of it just onto an external hard drive or onto a server without backing it up elsewhere. So think that you're paying for it twice or 3 times to store those data. With all of those, you need to think about, will the data be safe now and into the future? And this is where data repositories really come in to play as the ideal option. So to expand on the image I put in before, a key part of ensuring that the data are preserved well, the data are stored in the long term, is to deposit the data into a trusted repository. And I'll describe what I mean by trusted later. It's already been covered a bit today in Hella's talk as well. And then this allows you and others to reuse those data, and for others and yourself to build upon it in the future and make new discoveries. So all about data repositories. So a decent data repository will ensure the data is stored in the long term, the data are preserved, the data can be discovered, found, and that the data can be reused by others. It isn't an optimal option for active data management or code management, because it's static, it's kind of not interactive. And I think this is why those working with arches are thinking about, okay, what is the long-term prospects for preservation, because arches is very much as I understand it, an interactive open source database. So why use a data repository? Well, it's your best option if you use a trusted repository of avoiding data loss. Many funders expect data to be preserved in a repository. And journals will often ask for a data link. If you've written an article, they'll ask for a data availability statement and a link to those data. Others can reuse your data as well. And then these last few points are in blue, because I'm going to expand on these a bit later, because these really refer to the benefits to yourself as an individual researcher or as part of a research project or an organization, the benefits that there are to you for sharing the data in the repository. So these are to identify yourself or colleagues as authors of the data set. So putting kind of your ownership stamp on it, if you will. And determining how your data are reused by stating kind of what license you share your data under. And it's also the optimal way of getting your data cited and also celebrating your data outputs. I'm going to expand on these in a moment. These are just a list of some of the unsuitable alternatives for long-term data preservation and storage, and this is your own personal storage or group storage that you share. That's a risk of loss. It's the same for departmental and institutional servers, but there will be occasions where you need to restrict access to that data for ethical or legal reasons. We've touched on that again today. Minimally supported repositories is also a risk. There are thousands of repositories, data repositories out there, and it's really important to pick the right one so that you know that that repository is going to be supported in the long term, because some repositories can only last for a few years or so. The article supporting information, if you've done published an article in a journal, putting the data and the supporting information isn't the best way forward for preservation reasons. Likewise, a project website isn't suitable. And GitHub, while it's fantastic for code management and code sharing and also small data sets, it's not a long-term archiving solution for data in code, but there are ways of archiving GitHub code in, for example, Zenodo, which is a repository I'm going to focus on here. In terms of choosing a good repository, as I've said, there's a lot of choice. There are over 3,000 data repositories. So how do you narrow it down? So the first step would be to choose in this order. So if your funder says that you have to use a particular repository, then go with that one. And then there may be discipline-specific repositories that you could use. So Open Context, I would say, would be an example of one of those. In the UK, we've got the Archaeology Data Service. If you have one, then you could use an institutional repository. but not every institution has one of those. So then going for a general purpose repository is also a good choice if none of the above apply. And there are several of those, of which Zenodo is one. How to choose a good repository? Choose one that provides persistent identifiers. So a DOI is a classic and excellent example of a persistent identifier. That is a persistent link to your data that always enables it to be found. Repositories should have particular metadata standards that they use, even if those are fairly general. So this captures standard information about your data set that also helps it to be found and understood. You want to be able to apply a license to your data, which is your way of determining how that data can then be reused. Check the terms of use and see if they are suitable for you, and check policies that the repository gives regarding long-term availability and access to the data as well. You want to know if they have a succession plan. For example, if the repository goes down, where will your data end up if the repository is at risk of closing? And also choose a repository that doesn't charge users to access data. There aren't very many of these, and I've never encountered one with archaeological data before, so I think the risk of that is pretty low. And all of these together will help you to make your data fair, because putting your data into a repository is one crucial part of making sure your data meet the FAIR principles. These slides are being shared, so you'll be able to look into this in more detail, but there are various registries of research data repositories, and you can use particular filters in these registers to help you narrow down a search. For example, you can search by discipline, you can search by repositories that have, say, Core Trust Seal accreditation, which automatically makes it a trusted repository. You know it's going to be a repository that's looked after in the long term. So I suggest just having a nice look around some of those repositories when you have a spare moment. Okay, I want to give some examples now from Zenodo. So Zenodo is a general purpose repository. It welcomes research from all over the world and from every discipline. It's built on open source software. Its ethos is absolutely all about openness. The repository meets the FAIR principles. The content, and I think this could be quite relevant to some of you given how the conversations have gone today, the content can be made open or restricted. So if you have some sensitive heritage related, archaeological related data, for example, about endangered sites, then you can make the data restricted, and you can set the conditions upon which others can reuse, can access that data. So they can make a request to access the data, which you could either approve or deny. But the data will be in a safe place in a repository and stored in the long term, preserved in the long term. It takes all output types, so it could take articles and presentations, data sets, software code. It's got a good FAQs page. And interestingly, you can deposit as an individual, or you can create your own community as a collection of outputs. So to give you an example here, I did a search yesterday for just searching for the term archaeology, and there are already 73 existing communities with the archaeology tag. I did the same for heritage as well. This picture on the left gives you an example of a GIS and archaeology community that takes all kinds of materials, it says, related to GIS, applied to archaeology. But you can also create your own community, for example, if you're running a project. So the projects discussed today could create their own communities in Zenodo to house their materials, for example. And that's a good way of receiving contributions from others. So I mentioned these 4 items in blue, so I'm before, I'm going to focus on these because these outline some of the benefits to you. So I'm going to use an example because it's sometimes difficult to conceptualize what this actually means without an example. So this is an example data set in Zenodo. And I've just taken 4 screenshots of the record in Zenodo. You can see the DOI for it in the citation. So you can see the record. And the DOI is the persistent identifier. That's exactly what you want. It's a link that you can provide to your data set to tell people about it, whether it's in papers or whether it's in public engagement documents or blog posts or in your CV, for example, if you want to put together a list of publications. So your data set really is a publication in its own right as well. Like any article, it's a piece of work, and often they're major pieces of work. So they're things to be celebrated. So you can stamp the publication date as well, and the authorship as well, and that gives sort of a sense of ownership over the data set as well, which I know is of a concern to some. And this is sometimes a stamp that can't be given when the data set is sitting somewhere else on an external hard drive or on a server somewhere. You can choose the license for your data set. So for example, this one is a CC BY license, and it basically means that anyone can reuse this data set in any way they like, and as long as the authors are cited in any reuse of that data set. You can apply, for example, a non-commercial license on top of this, which means that your data can't be reused for commercial purposes. So there are various different choices that you can have. You can get statistics on how frequently your data set is being looked at or downloaded, which is a quite nice way of addressing kind of the impact of your data set that you've published. And then also you can get information on citation, so you can expand that mark there and have a look at where the data set is being cited, and obviously by whom. Now you could take it one step further. So I mentioned before about celebrating your research data sets. So one way of doing this is to write a data paper. So I've included 2 examples here from the Journal of Open Archaeology Data. And this is essentially a short article, perhaps 2,000 words or so, where you describe a data set in detail. And that paper itself gets a DOI that you can cite. And also within the paper, you link to the data set itself in a repository. So the example on the left is the data paper version of the Zenodo data set that I just ran through in the previous slide. On the right-hand side is an example of another data set, another data paper, and the data set associated with that paper is deposited in a different repository. This one is called Figshare, which is another general purpose repository that's also commonly used by people in any discipline. So just to finish now on a final slide, I just want to summarize some of the key points from this talk. So consider data preservation throughout a project and not as an afterthought, but it's never too late to start good practices. Curate your data. I think archaeologists are excellent at curation. So this is to save your data in friendly formats, organize and describe your data files, keep 2 backups at least, decide what to keep and what to delete, and deposit in a repository. And finally, think of the data sets that you produce as research outputs in their own right. They are publications in their own right. So if you share them and share them well, your data can be reused, credited, and built upon in the future. So this is to your benefit, as well as to the broader benefit of research and society. Okay, and that is it. So I'll stop sharing now.
Brilliant. Thank you so much, Sacha. It's really great to have all of those links and useful information as well for where people can go and find out a bit more. Does anybody have any immediate questions for